Welcome to qnawire.
This is a question of binomial distribution. What exactly is a binomial distribution? Binomial distribution is the probability that my x, my random variable capital X, is equal to small x. That is, there are x successes. This is given by NCM, let's say. Out of n trials, I want m successes. P is the probability of a success. This raised to m. And what is going to be the complement? 1 minus p. This is the probability that there will be a failure. So this is going to be n minus m. This is the general form of a binomial probability distribution. Now, either there will be a robbery or there won't be. So there are only two possible outcomes, right? Let us look at the question. Now, they are saying that in a recent study of robberies for a certain geographic region, it was found that there is one robbery per 20,000 people. So, what is the probability that a robbery will occur? It is 1 divided by 20,000. So, if I use my calculator to find this is going to be 1 divided by 20,000. This is 0.00005, which is really small. Okay, so let's say that we consider an event to be a success if the robbery occurs. Okay, now we have a population of 80,000 and we want to find the probability that zero robberies will occur. So this is the first case when zero robberies will occur. Zero robberies, which means what? Number of successes is zero. What is n? N is 80,000. So this is 80,000. And C, how many robberies do I want? I want zero robberies. What is the probability of success? That is probability that a robbery will occur. It is 0.00005. This raised to the number of successes, which happens to be zero in this case, multiplied by the complement of 0.00005. This is 0.99995, and this is going to be raised to n, which happens to be what? 80,000 in this case. So this is going to be raised to 80,000. Okay, because what is a success in this case? A robbery is considered to be a success, right? And there are zero robberies, which means there are 80,000 trials which happen to be the failures. So this is the probability for that. Okay, so what? How do we write NCM, or how do we write 80,000 C0? This is going to be 80,000 factorial, or okay, let's just simply write this as 1, because we know that NC0 is equal to 1, right? So this term over here, this becomes 1. 1 multiplied by anything raised to 0 is again 1, multiplied by this thing over here, 0.99995 raised to 80,000. And if I use a calculator to find this is 0.99995 raised to 80,000. This is turning out to be 0.0183. 0.0183. This is going to be our probability for the first part. This is our first answer. Okay, moving on to the next part. Now, what are they asking? Find the probability that there will be one robbery. Okay, so now this is going to be 80,000 C1 multiplied by 0.00005. This is raised to 1 multiplied by 0.99995 raised to 80,000 minus 1 is what? 79,999. All right. So NC1 is what? N. So this is going to be 80,000. This becomes 80,000 multiplied by 0.00005 multiplied by this thing. So if I use a calculator to find this, this is turning out to be 80,000 multiplied by 0.00005 multiplied by 0.99995 raised to 79999. Okay, this overall answer, I've calculated this overall thing. My overall answer is coming out to be 0.0732258. This is my answer for part B. This is the probability that my x is equal to 1. So let me just write this over here. Probability that my x is equal to 1 is this. Over here, I can say that probability that my x is what? Number of robberies is equal to 0 is this thing over here. Okay, we are done with part B as well. Moving on to part C. What does part C have to say? Probability that there will be 2 robberies. So I have 80,000. Okay, this is 80,000. C 2 multiplied by 0.00005 raised to 2 now. Okay, multiplied by 0.99995. This is raised to 79,998. Okay, how do I write 80,000 C2? I can write this as 80,000 factorial upon 2 factorial into 79,998 factorial. Right? I can write it like this. So what I'll do is I'll write this as 80,000 into 79,998. Sorry, 999 into 79,998 factorial. These two things get cancelled. This thing actually becomes 40,000. All right. So this is going to be 40,000 into 0.00005 raised to 2. This is multiplied by 0.99995 raised to just a moment. Okay, 99995 raised to 79998. All right. So the thing is that this answer is turning out to be 0.1465. Okay. This overall answer, if I calculate all of this answer boils down to 0.1465. 0.1465. So what you have to do is you simply have to put the values in the calculator and get your answer. I'll leave this calculation to you guys. Very simple. Just use the calculator. Now part D. Now this is very interesting. Part D says 3 or more robberies. More robberies. Right? Alright. So how do I get this? Can I write this as 1 minus probability that my x is equal to 0 plus probability that my x is equal to 1 plus probability that my x is equal to 2. Of course, I can write this, right? This is going to be the probability that my number of robberies is going to be either 3 or more than 3. From total, I am subtracting probability of 0, 1, and 2. So, do I have these answers already? I think I do. In part A, it was 0 robberies, so it is 0.0183. This is 0.0183 plus in part B, we had 0.0733. 0.0733. I've simply rounded this off, and then I have 0.1465. 0.1465. Okay, so if I use my calculator, 1 minus 0.0183 plus 0.0733 plus 0.1465, and this is 0.7619. 0.7619. Okay, this is the answer to my final question. This is probability that my x is greater than equal to 3. Okay, this is my answer, and this is how we go about doing this question.